Alrighty guys, it is April 17th, 2020. It's Dr. B. Your Molality lab simulation was due today, and we have a new lecture, homework due on the 21st. So you're probably wondering why this meme. Well, if you look, we're talking about a new topic today, molality, different than molarity. And if you're still stuck on stoichiometry, I hope that's not the case. That's all I'm going to say. Alrighty, so we are going to cover a new topic. They are called the colligative properties of solutions. This is our big topic, and we're going to cover these things today. More so these two right here, converting temperatures, molality, and the colligative properties themselves, which we'll cover on the next lecture. Alrighty, so the first thing we're going to do is talk about converting temperatures. So you should know how to do this. I'm going to go over it again one more time. On the right side of the slide, you see this whole map of all the countries and continents, etc. You'll notice that there's only a handful of places that still use Fahrenheit. Everyone else uses Celsius. So, alrighty. There's also a video on why we're one of the only few countries that still use Fahrenheit and everyone else uses Celsius. Alright, so to convert Celsius to Fahrenheit, here is the equation. So degrees Fahrenheit equals 9/5 times degrees Celsius plus 32. Fahrenheit to Celsius, so that means I'm trying to find Celsius. So to get Fahrenheit, I do 5/9, and in parentheses it will be degrees Fahrenheit minus 32. And to convert Celsius to Kelvin, so I'm trying to find Kelvin, you got to add 273 to Celsius. Okay, so let's work on some of these problems. You're going to have a few of these, I believe. So I want to get from 45 degrees Celsius, so Fahrenheit to Celsius, I'm sorry. So write down my equation. And plug in my numbers, etc. And I end up with 7.22 degrees Celsius. So for now, you can use your whole numbers for these temperatures. All right, degrees Celsius to Kelvin. So I have to add 273 to my Celsius right here. So Kelvin equals 150 degrees Celsius plus 273. I end up with 423 Kelvin. And now I want to find Fahrenheit from Celsius. So I got to plug in my 200 into my Fahrenheit to Celsius equation. So 9/5 times 200 plus 32. The reason why I'm asking for whole numbers is you can see that you have 200, but if you did by sig figs, it would only be 1 sig fig. So 392 degrees Fahrenheit, and box that in. Alrighty, very cool. Alright, so colligative properties. So these are properties that only depend on the amount or concentration of the solutes and not exactly what is in it. So we're focused mainly on just what is the amount of particles. So this is more of a quantitative quality, a quantitative focus, if you will. Quality means you're focusing on what it is. Quantity is how much of it. So before we actually get into the colligative properties, we got to talk about something called molality. So molality is different from molarity. Molarity, if you remember, capital M, notice how I'm specific, is moles per liter. Molality, lowercase m, is not. Here is the equation. It is moles of the solute divided by the mass of the solvent in kg. So it's moles over kg. That is lowercase m. So similar to before, you can rearrange this. For example, if I want to get moles by itself, I have to do a different color, multiply both sides by kg. So if I want to get to moles by itself, I got to multiply both sides by kg. And there you go. I'm now solving for moles right there. If I want to solve for kilograms, so the mass of the solvent, let me rewrite the equation. So again, multiply both sides by kg. That cancels out, but now you got to see, I got to get kg by itself. I'm going to divide by molality on both sides. So you end up with kg equals moles divided by lowercase m. That's if I want to solve for kg. Again, be careful. Be aware of your capital and lowercase. That's why I took off from your homework if it looked like a lowercase letter on your assignment. Alrighty, so how to solve for molality. So if you dissolve 350.0 grams of potassium chromate in 2.50 kilograms of water, what is molality? So molality, again, is moles per kilogram. So I already have my kilograms right here. So I'm good with that. However, I only have grams of my solute. I got to convert that to moles. So similar to before. So 350.0 grams, convert this to moles. So I got to get the molar mass of potassium chromate. And that is going to be 39.1 times 2 plus 52 plus 4 times 16. That's 194.2. So I divide these two numbers and I'm going to get my number of moles, which is about 1.802265705. I'm going to plug that in on top. 1.8022, etc. divided by my mass, my kilograms of water, my solvent. So it's not always going to be water. It may be something else. You just got to pay attention to the question. So 2.5 on the bottom, 0. So my answer is going to be that 1.880 something divided by 2.5. I'm going to end up with 0.720906, blah, 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 blah. Molality. So my answer is going to be, depends on how many sig figs I have, which is going to be, I have 4 here. Then I have 3, so it's going to be 3. 0.721 lowercase m K2CR